class once again. We are going to continue in our class of measures of central tendencies, but today we'll be looking strictly at median and mode. And by definition, median can simply be defined as the centrally based data, the centrally concentrated data in an array. An array is actually an arrangement of data either in the ascending manner or descending order. That's what we call median. So that definition suffices when we are dealing with an ungrouped data. But the moment we launch into group data, then the formula changes, and it's nothing less than median equals to LME. Now, where I have my LME is called the lower class boundary of the media class, then plus in brackets capital N over 2. Your capital N also means summation F, which is the total summation of your frequency divided by 2, minus CF less than FME all over FME all in brackets C. Now, what does CF mean? CF denotes cumulative frequency less than the frequency of the media class all over the frequency of the media class. That is what that simply connotes. And this formula is what we'll be needing when we are dealing with with grouped data. But the moment we switch to mode, now the formula for mode is simple, but we need to understand the definition. For what you do not define, you do not know. So by definition, mode can simply be defined as the most occurring data in a given set of distribution. So any data that appears the most in a given set of distribution is otherwise known as what? As mode. And a distribution can be unimodal. Now, unimodal in the sense that just one data as the occurs the most, while it can be bimodal. Bimodal means two data means a given set of data occurs the most with the same frequency, and it can also be polymodal as well. That the definition is actually self-explanatory. By definition, and that's how it's going to be if I was dealing with an ungrouped data. When I just look at the data and I discover that this particular data is appear the most, then it becomes my mode. But when I am dealing with a grouped data, I need to consider another formula, and the formula for group data of mode is given as what? Is given as mode equals to LMO plus open bracket F1 minus F0 all over 2F1 minus F0 minus F2 all over all in bracket rather. Where we have our LMO implies the lower class boundary of the modal class, and our F1 implies the frequency of the modal class, and our F0 means the frequency of the preceding class. That means the class before the modal class, the class just before the modal class, all over 2 times the frequency of the modal class minus the frequency of the preceding class minus the frequency of the succeeding class. Now, the succeeding class is the class just after the modal class times your class size. And our class size still sustains its definition of being what? Of being upper class boundary minus what? Minus lower class boundary. That is how we're going to be getting our class size. Now, if you go by example, some of this form as our example. Now, if for instance we are given our class size to be of this form and our frequency to be of this form, then how do we generate our x value? And our x, like I told you, is otherwise known as your mid class or your class mark. Now, how do I get my mid class? I'll add up the lower class interval plus the upper class interval, and I'll divide it by 2. So I'll be having it to be 2 here, and here I'll be having it to be 5 here, and here I'll be having it to be 8 here, and here I'll be having it to be just 11. Then I'll be having my class boundary as well. My class, what? My class boundary. Now, by my class boundary, what do I have? I'm going to be subtracting 0.5 from my 1, adding it for my lower class interval, and I'll be adding the 0.5 to the upper class interval, then 3.5. Subtract it from 0.5 from 4, I will have 3.5. Add it to the upper class interval, I will have 6.5. Same occurs with the rest as well. I will add and I will as well what? I will as well high. Then I will have my class boundary to be of this form. Then the next thing I need to complete my table is my cumulative frequency, which you can also denote with our capital F. It simply means the same thing. So how do I generate my cumulative frequency? I will have my 5 first written here. 5 plus 3 gives me 8. 8 plus 4 gives me 12. 12 plus 2 gives me 14. Then my total frequency as well is also what? Is also 14. Then my table is set to compute my median and my mode. What am I making? Now, how do I compute it? All I just need to do is that I have to follow my formula dogmatically. Since I understand what each denotation stands for, then it's just easy to compute. Then what do I have? I want to start with my mean first, then my median rather first. What do I have? I have the formula of my median, as you can remember, to be what? To be the lower class boundary of my median class plus my what? My total frequency all over 2 minus what? Minus cumulative frequency less than the frequency of the median class all over the frequency of the median class, all in brackets my class size. Then what do I do? The first thing I'm going to do in the median aspect is that I'll come right here to estimate or to know what this value stands for. I know that is solution Fi, so I come here and I have 14 all over what? All over 2, that's my solution F, minus, now that's that should be 7, 14 divided by 2 is 7. So I come straight down to my cumulative frequency and I try to scan through to know where 7 can fall into. So I know 7 can fall in 8. I can find 7, 8. So this row automatically becomes my median class. For that purpose, I'm going to say that the lower class boundary, the cumulative frequency less than the frequency of the median class is just 5. All over what? All over the frequency of the median class is 3. You know, I just said that this row becomes our median class because our 7 falls right here. Then close the bracket. Then the lower class boundary of our median class is 3.5. So I write 3.5 here. That is my class size. How do I get my class size? Now this is a regular class size. 3.5 minus this minus this minus this minus this will simply give me 3. So I'll be having 3 to do my class size. Then I just do my simple computation, my simple mathematics of 3.5 plus all in bracket 7 minus 5 over 3 times 3. So 3 takes away 3. By mathematics, I have 3.5 plus 2, and that is 5.5 as my answer. Now, that's my median, and it can actually be found, but the value can be found in between my class boundaries of my class, median class. So that is that for that in solving median. And it's just so literal. When you are given any course of such to solve, just go that way, and you will just be fine. But if you are to compute for mode, we also go literally by the formula. Now the formula of mode for group data is just what I gave you initially, to be LMO plus in bracket the frequency of the modal class minus the frequency of the preceding class all over 2 times the frequency of the modal class minus the frequency of the preceding class minus the frequency of the succeeding class all in bracket the class size. So what do I need? Is that I come down to my frequency and I try to check the frequency that occurs the most, and that is 5. So I will label it F1. So unfortunately here, we do not have a preceding class. So I will just label my preceding class to be what? To be 0, since there is no preceding class. For my succeeding class is 3, so I will label here to be F2. So on that note, I have my LMO, the lower class boundary of my modal class, as well to be 3.5 plus in brackets my F1 is what? Is 5 minus my preceding class, which does not exist. I call it 0 all over my 2 times 5 minus my frequency of the preceding still is 0 minus succeeding class, that is 3 all in bracket 3. So I'll be having it to be what? 3.5 plus all in bracket 5 open bracket 10 minus 3 times what? Times 3. Then you'll be having it to be what? 3.5 plus 5 times 3 all over 7. So with this, you can just be sure by simple computation with your calculator that 15 divided by 7 will give you what? 2.13 thereabout. By adding it together, you'll be having to be what? 5.63 as your modal value. So that is that for that in computing the value for mode as well. And it can just be that literal, just literal. So if you have a question of this form or any form in class interval or giving x value, you can simply go this way and I'm sure you will just be fine. Now we're going to be looking straight ahead into the measure of dispersion, and we are going to explain it to a reasonable extent, and we are going to understand the concept of the measures of dispersion and the measures of variation. In measures of variation, the concept behind it is that you are given a given set of data that you have either rough or organized data from x1 down to xn. Then you have actually computed your mean x bar. Now our aim in measures of dispersion is to know how far apart each value xi, that means x1 down to xn, is far away from the mean value. Don't forget that the mean value is actually one single value representing a range of a given range of values. So what x bar does is that it's a point estimate representing a given set of value in their ranges. And we try to measure the degree of discrepancy, the degree of variation of each data from their mean with respect to their mean. So that is why we come about the measures of dispersion or the measures of variation. And we have various of them actually, but we're going to talk about the popular ones that can easily make us relate with other ones, and include the standard deviation, your variance, your range, your mean deviation. And basically, although you have your semi-interquartile range, your coefficient of variation, and the likes of them, your square root and kurtosis. And but let's discuss this four first, and in perhaps in our succeeding classes, we'll be discussing things related to that. Now, and basically, we need to understand formulas here. Basically, formulas, we have to get related to them. Not Bogus formula actually, but these formulas are needed for us to be able to have a sweet sail in computing of numbers, some numerical values. By formula, variance is denoted by sigma squared, and we do write it as variance of, say, xi, that means range of values of xi. All of these still mean the same thing. Is the summation of I ranging from 1 down to n of x minus x bar in bracket squared all over capital N. This is when I don't have a frequency, just my normal group data. But the moment it becomes a group data, then the formula becomes the summation of f of x, fi of xi minus x bar squared, I ranging from 1 down to n, all over capital N. This actually talks about the computation of variance when it includes frequency. Now, it's as easy as this, in the sense that your standard deviation, which in most cases we denote as XTD, not sexually transmitted disease, just standard deviation. We denote it with sigma, perhaps, of x equals to just the square root of variance. So the moment you compute your variance, you can easily find your standard deviation by just square rooting your standard deviation. You'll be having your what? Square rooting your variance, you'll be having your standard deviation. And although there are other formulas related to this, because you can have formula for variance to also be the summation of f of x squared, fii, all over capital N minus the summation of f of what? Fi of xi, or perhaps xi, all over capital N, all in brackets squared. And you can also have it in form of assumed mean. Fine, it's also cool. You can also have it in form of assumed mean. But I don't want to bore you with too many formulas actually. I do not want to bore you with too many formulas. So I'm going to be sticking just to one formula, and that is the first one I wrote for you on the board. This and this. Okay, basically, I'm going to be sticking to this. Others too we do fine, but it's something you can easily relate with the moment you understand this method. So, like I said, variance is just find the square root of that, and you're just fine. Now, for mean deviation, it could be a different ball game in the sense that your mean deviation, let me say MD, is equals to the summation of I from 1 down to n of your fi with a modulus of x minus x bar, xi minus x bar, all over your capital N involving frequency. Now, it's not bracket, it's modulus, so we're doing the modulus function here. That is every of the variation that occur between the mean and its x value are being being quantified to be positive numerical values instead of negative. So if anyone ever turn out to be negative, we're going to change it to positive, and we're going to be looking for the mean deviation that way. And your range is happens to be one of the simplest formula you can come by. Your range is just simply the maximum value in the in xi, set of xi, and the minimum value instead of xi, and that is just fine. So let's quickly look at one example and we will round it up from that example. And we're asked to solve for our variance and our standard deviation with our mean deviation and our range. Then how do we go about it? It's just simple. We try to complete our table, complete it in a full manner. Solve for your mean first. That's the first thing I'm going to do. That's your x bar being what? The summation of what? Of fx all over capital N. So I need to solve for my capital fx here. 2 times 3 is 6. Here is 6. Here is 4. And here is 10. So I need this and I need to sum it up. When I sum it up, I have 6 plus 6 to be 12. Plus 4 to be 16. Plus this to be what? To be 26. And all over what? My total frequency, 3 plus 2 is 5, 6, 7, 8, all over 8. So with this, I'll be having 28 dividing 8 will give me 3.25 as my mean. Then I'm going to be solving for my x minus x bar. I'll be solving for my x minus x bar squared. I'll be solving for my modulus of x minus x bar. Then I'll be solving for my f of x minus x bar squared. Then I need one more thing. F multiplied by what? The modulus function I made mention of. Then with this table, I can easily compute for my mean deviation, my standard deviation, my variance, and my range. Then with this table, what else do I need? I need to, like I said, compute this. So my x value, x minus this, what will I be having? I'll be having 2 minus this to be minus 1.25. Then subtract this as well is 0.25. 4 minus this is what? Is 0.75. This minus this is what? Is 1.75 when I subtract it actually. Then I'm going to be squaring it up. When I do my simple squaring, what do I have? When I do the simple square, I have it to be here to be 1.5 in 2 decimal place. I have this square as well. When I square this, what do I have? I have it to be what? To be 0.0625. Here I have it to be 0.75 just squared. To be what? To be 0.5625. Then I have this last one to be 1.75 squared. To be what? To be 3.06. Okay, like I said, to be 2 decimal place so that we can easily handle data 6, and we are fine like this. Then the next thing is to find the modulus of this function. So I have 1.25. I have 0.25. I have 0.75. I have 1.75. Now just the same data, only that we needed to remove anything that have to do with negative, if there is, from this column and transport it here. So I need my frequency multiplied by this. So 3 times what? 3 times 1.25 will easily fetch me what? 3.75. Then 2 times this will give me what? 2 times that is what? 0.5. I have it to be 0.5. Then I have 1 times this to be the same thing as 0.75. And 2 times this to be 3.25. So 2 times 1.75 will give me what? Will give me 3.5. Then my same frequency multiplied by this modulus, what will I be having? So I have 3 times 1.25 to be what? To be 3.75. Still, am I sure? 3 times this will give me 3.75. Then I made the mistake here then. So it should be 3 times this 1.5. So 3 times 1.56. What does it give me? It gives me 4 points. Okay. 4 points. Okay, you know what? Let me just leave this as 3.75. Why I changed this to the modulus of what of x, because I discovered that what I did was to solve for x. Then here we just simply be what? Simply be the squared, so that I can easily solve for that. So I have 3 times my square here. So 3 times 1.56 to be what? To be 4.68. Then 2 times what? 2 times this is 0.06 to be what? To be 0.12. Then 1 times this will give me 0.562. Then 2 times this, so 3.06 times 2 would give me what? Would give me 6.12 as my answer. So I need to find the sum total of this guy, the sum total of this guy, and I'm just fine. So when I find the sum total of 3.75 plus 0.5 plus 0.75 plus 3.5. So what else do I have? I have it to be 8.5. And adding up the next column is 4.68 plus 0.12 plus 0.56 plus 6.12. I'll be having to be what? To be 11.48. Then with that, what I need to do is that I just need to solve for my what? My mean. Sorry, my mean deviation. So my mean deviation, let me say MD, will simply be what? The sum total of all of these guys, 8.5, all over total frequency is given as 14, right? 3 plus 2, sorry, is 5, 6, 7, 8. I mean 8 equals to say 8.5 divided by 8 will give me what? Will give me 1.06. 1.06 if I'm putting to 2 decimal place. So that will be my mean deviation. But when I'm dealing with my variance, when I'm dealing with the variance, I will simply be having it to be what? The summation of all of these guys, which gives me 11.48 all over what? All over 8, my total frequency. So when I do a simple division using my calculator, I'm just going to be having 1.435. Hence, my standard deviation, like I said, is the square root of my variance. So all I do is find the square root of this variance, 1.435, and that will give me the square root of that. My answer is just 1.19. So if I approximate that, it to be 1.20. Then my range is just simple. I have my range value to be what? To be my maximum value of x, which is 5, minus the minimum value of x, which is 2. So the range value is what? Is 3. And with that, we have easily solved for our mean deviation, our standard deviation, our variance, and our range. And that is going to be that easy. All we need to do is what? Is to understand the formula, understand how the table is computed, and we'll just define. So stay put, and please do ensure you're subscribed so you can get information on when we come up with a new and informative video. Thank you.